G'day there everyone. I just want to show you some more about the magnetic fields on these coils. So I've got the big quad filler BAC running at the moment. And as you can see, it's triggering my Gauss meter quite a lot. That's topping off at 5 milligauss. I'm going to change the sensitivity and we'll see if it keeps reading. No, we've lost it. So we've only got a little bit over 5 milligauss. On this setting it goes from 1 to 50 milligauss. On the other setting it goes from 1 to 5. And as you can see, I just switched it back and it's still... Oh, there we go. What if... Yeah, not to the same extent. It often fires off a little bit like that when I turn it on. But there is a field. You can see when I move my probe around a bit. Now you've got to hold this probe pretty stationary. If I move it around like that, you get false readings. Okay, if you just leave it sitting still, nothing. Unless you point it at the middle, really close. So there is a magnetic field in the centre of that. I mean, playing around with putting bolts and magnets and things in there, it does affect the way the circuit runs. If you put magnets in there, it can change the resistance and the amp draw and things like that. Well, it's not going to change the resistance, but it changes the amp draw and makes your lights go dimmer and brighter. And that's on low sensitivity. And so it's not a huge one on this coil. On the smaller speaker wire coils, like this one here, it does go a lot higher, but I think that's because they've got a closer, tighter winding in the middle. So I'm going to have to experiment with that some more. I did originally wind this with 2 extra windings in the centre, but I really wanted my connection points at the edge, so I've decided to sacrifice 2 windings for that. You can also see here I have my magnoscope going again, so you can see those field lines. So I'll just turn it around so you can see that I'm not messing with you. And you can see those field lines starting to form up now. You've got to be very close to the coil. Okay, I don't know how well the camera's showing you that, but I can see a bunch of squiggly lines forming up, radiating out from the centre of the coil like this, or possibly towards the centre of the coil. So we'll turn that again and I'll give it another go, see if you guys can see it now. Alright, I think you can see that time. There's definitely forming lines there. So there's some interesting magnetic effects going on with these coils. Now, this one will do the same thing. If I stick the little neodymium in the middle, it'll stand up every time, unless it doesn't land in the middle. And it sticks to the tape. This isn't a very good explanation, is it? There you go. Right, couldn't even see. Sorry about that, folks. See that? And it sticks to the coil. I've noticed that with the other ones too. So we are forming some form of electromagnet there. You can see there's no way you'd normally be able to get that magnet to stand there like that. Okay. So I don't know what to make of any of that. All I know is that there is magnetic fields going around this coil, and that messing with them does affect the way the circuit runs. Now, while I've still got you here, it's probably been an hour since I turned this circuit on in the last video, which is being compressed for upload as we speak. And you can see that extra LED I dropped down in there just under all the froth. Look at all that extra froth coming straight up from where those LEDs went. So even that first one that I dropped in here, that we didn't think was electrolysing, it is. And I don't know how well you can see in there now that that's all cleaned up a little bit. But those LED legs are rusting up pretty good. They will have grown quite a considerable, especially the ones around the edge. And these guys up here, there should be growing some considerable amounts of rust on them, and you'll notice it's often on the positive sides. Nearly always on the anode first. Okay, that's about all I got for now. Thanks again for watching.